It wants the angle x, doesn't it? Yes. Uh, so this is what's called a straight angle. Can anybody tell me what angle this would be? Why is it 50? Yep. Now, what type of triangle is ODB? How do you know it's isosceles, good man? Two of them are radiuses, aren't they? Radii. So what does that mean about these two angles here? They're both there. They both got to be the same, don't they? All three angles has to add up to 180, don't they? If you're obviously filling this out as we go along, if you or don't have it done. So 180 take away 50. 130 divided by 2. Huh? 65, okay? So they're both 65s. And those workings I did, they'll obviously go down on the, they'll obviously go down the bottom. All right. Now, well done. AOD. What's, oh, sorry. X is, that's, I did part 2, didn't I? Part 2 is 65. And part 1 is ADB. Which one's ADB? Ah, that thing. All right, guys. It's called it's called angle in a semicircle, okay? So for those of you who don't remember this rule, it's one of the rules we learned off by heart. Anytime, so the way to explain it is like this. Anytime one of the lengths is the diameter of the circle. Everybody see the center of my circle? Would everybody be happy that this is a diameter then? Okay. No matter what third point I pick, so they're the two diameter parts. No matter where I put my next point, doesn't matter what part I put it at, provided it's on the circle, doesn't matter where I put it, provided it's on the circle, it always makes a 90-degree angle, provided it's on the circle. This is what's called angle in a semicircle. So we know that ADB has to be 90 degrees. Is that okay? Doesn't matter where I put it on the circle, it's always going to make 90 degrees. Okay, cool with that. Next question. This one. Radius is 18 centimeters. Find the length of the arc AD. Give your answers in centimeters. Now, what we're going to do next is, so the radius is 18. Find the arc, radius circle is 18. Find the arc AD. Okay, I have to go back here to the diagram. Okay, I'm just going to rub out all this. What does the arc AD mean? Let me tell you what the arc AD means. That's what's called the minor arc AD. What do we mean by minor? The small one. This one's called the major arc of AD. See the way you can go around the other way? Unless it specifies otherwise, they're always after the minor one. Is that okay? Now, there's a formula in your tables that does this. So we're after the blue line. Everybody cool with that? There's a formula in your tables. Can anybody see the word arc in your tables on either page 8 or 9? So you're looking for our piece of slice and a circle. So we're essentially trying to find the crust of a pizza, the length of a crust of a pizza. Does anybody see anything in their tables that will do the trick for us? What you see? Yeah. All right. L equals theta. No, that's honors level only. The other one. Theta over 360 multiplied by, that's area. That'll give you the area of the pizza. 2 pi r. Everybody see that one? Okay, that will tell me the length. What numbers do I have to fill in? Again, yeah. What numbers do I have to put in to that formula to make this work? What did the second radius was again? Says on parts C. Huh? It's 18. Okay, radius is 18. Awesome. And what about the theta value? What's the angle in your what's the angle that looks at it? 130 exactly. So we're going to do 130 over 360, and we're going to multiply it by 2 pi times 18. Okay, and we're going to get out the old calculator and we're going to lob it in. Okay, 2 pi, and then we're going to go for 18. You cool with that? What do we get? 13 pi, and for argument's sake, this is how I did the question. Okay, I'm just going to copy and paste that onto the next part. Okay, and that's my calculation here. Cut it. Oh, it's just the angle that faces the slice. So an example would be, see this slice here? Okay, so an arc is the arc is the black sorry, the arc is the blue line here. Do you see the blue line? And the theta is whichever angle looks at that. So if that was 50, the theta value would be 50. Is that all right? And it says in terms of pi. So in terms of pi, we're looking at 13 pi. Is that okay? And we get that out. Good man, Jake. How about you, Sean? Yeah. We all good? Right. Now, two statements are shown. If two triangles are similar, they must be congruent. What does that mean? What does similar mean? Anybody similar? Same shape, but not the same lengths. So give me an example, all right? See this one here? Okay. I'm going to grab this, I'm going to clone it. If it's a clone, these two are congruent. Why are these two congruent? They're the same in every way, shape, and form. They're similar and they're congruent. However, a statue of me is similar to me, but it's not identical to me. Do you get what I'm saying? So if I enlarge this, what can you say here? Yeah. So what you could do is you can make yourself an equilateral triangle, okay? Something really easy, okay? And what you're saying is, and then you can make this one of length 3, 3, 3. You can make the next one of length 6, 6, 6. And what can you say? Same shape, different lengths. See what I'm saying? No, false. Same shape, different lengths. Same shape, different lengths is similar but not congruent. You can always look at the back of the book, read what they give you, and if you understand what they give you, just remember. Okay, it's your choice. We all good? Okay. Now, is there parts? Oh, another one. If two triangles are congruent, they must be similar. True or false? Why is it true? Yeah, go on. Yeah. So congruent triangles, the angles have to be the same. Okay. So these are congruent triangles, and you can just say incongruent triangles. Angles must be the same. So the angles must be the same, hence they are similar. We all cool with that? Okay. Now, on to question 7. We all good? Everybody take out a calculator if you have it. We might need them. Okay. They decided to. So what they did is they took a bunch of animals into a shelter. Okay. So these usually when you take an animal into a shelter, It's because they're not being looked after well and they're often underweight. A couple of days later, so the green section is when you get the animals initially. The blue section is what happens to the animals a couple of days in the shelter. By and large, what happens? They all get heavier because they're getting fed better. Correct? Great. Now, we're going to do what's called a stem and leaf plot. Okay, down here. Okay. Now, the best way of doing this is we'll start off with the fours. Oh, it's in order size already. So what can I put here? 5. And the next one? 9. And stop there. That's 5 and 9. Okay. And does it have a key? So the key could be, you're meant to have a key on both sides. So I could say 5/4 equals, what does 5/4 mean? Actually, it means 4.5 on the left, but on the right hand side, it would mean 5.4. It depends what side you're talking about. On the left side, it means 4.5, but on the right side, it would actually mean 5.4. Depends what side you're on. Okay, now keep filling this in, obviously, as you go along. All right, what do we have next then? 3, 3, 7. Then 6, 9, then, okay. Next one, 8, 4, 5, 1. Whoa, it's in the wrong order, isn't it? Sneaky. So what's a 0, 1, 3? Yeah, 1. Are we cool with that? They're nice handy marks, aren't they? Do a diagram, here's some marks, all right? Happy days. Okay. What does the 7-leaf plot show you about the weights of the dogs on day X and day Y? They're getting heavier on day Y. They are, in general, all heavier on day Y. Cool. Right, let's move on. Or is the correlation coefficient between day X and the weight on day Y? Based on a data table, pick the most likely value of R from the list below. Give a reason for your answer based on the data in the table. Okay. Correlation between day X and day Y. Okay, does everybody remember what correlation coefficient is? Anybody remember? No? Right. Correlation coefficient is how one of them relates to the other one. So what we would have had back in the day was we would have had height and weight. Okay. And what we would have said about height and weight is that the taller you are, usually the heavier you are. Do you get what I'm saying? So what happened is we'd have a bunch of heights and weights of people. So I'll give you an example. This point here could be the point, I don't know, 85, 185. That's somebody who's 185 centimeters tall and weighs 85 kilograms. Does that make sense? This point down here could be something like 50 and 150. Somebody that's 150 centimeters tall but only weighs 50 kilograms, all right? We all good with that? So what we're saying is there's a positive correlation because as you get taller, you get heavier. And there's a strong correlation. So it's positive because it's going uphill, isn't it? And because all the points are really close to the line, we say it's a strong correlation. Does that make sense? Now, if it was something different, like can somebody name something? What gets smaller as the other one gets bigger? Anybody tell me? Let's make up an everyday example. Try and think now. What gets smaller as the other one gets bigger? What? Potentially. Give me a sec. Okay. Number of hours on social media. skill grades. So the idea here is that the longer you spend on your phone, the less time you'll spend studying, the lower your grades. Would you agree with that? Okay, so somebody who spends so for argument's sake, that's 100%, and for argument's sake, that's like what being like hours per day. Imagine 8 hours per day on your phone, right? 8 solid hours on your phone a day, all right? And that'd be 4 hours, and that's 50%, right? So what we're saying is that there's some lads I know. There's a lad in my old school where he didn't actually use a phone at all, and the guy was a genius, right? So he doesn't spend much time on his phone. He gets close to 100% a lot of the time. We have another guy who's always on his phone, very distracted. He's getting around 40% because he's on his phone so much. So to agree that we call this a negative correlation. That the longer you spend on your phone, the lower your grades. Does that make sense to you guys? And this time it's a negative slope. So an answer like that would be minus 0.9. Does that make sense? Here with you guys? Now, if I look at the figures from the last diagram, okay, so if I was to quickly draw up, I'm only going to draw two or three of these. Alex, will you give me, when you have a chance, all right, will you call out three of these results for me? You call me out result A, result D, and result H, just in a minute's time, okay? All right, you guys? Now, what's the weight of the first one, Alex? 4.5 kilograms. So I'll call this day Y for me, Y axis, and day X axis. I think they meant that. Okay, so what's the day X weight? Okay, and what's the day Y weight? 4.5 about here, 4.8 about here. That's that point there. Pick the next point. Yeah, day Y. Okay, grand. And the next one? Yeah. So I can clearly see that this is a positive correlation. So what would that mean? Rule out all negative answers. You go with that? And then the only answer is 0.9. Is that okay? That it's if you were to draw it out, it has a positive slope. See the way I didn't draw them all out? See the way I only need to draw three of them just to get the gist? Okay. All right, let's keep going. Oh man, yes. Yeah. Okay. There's 14 dogs. Sorry, 14 cats. There's 40 animals in total. What do we say about this part here? Nope. 26. Have we killed 26? What do you think about this part here then? 15. This part here. And this part here. 24. We all killed that? You found that handy enough last night? Right. Now, three different animals were picked at random from the animals in the shelter on Monday. Find the probability the animal picked was a cat. Okay. How many animals was there in total? Well, how many of them are cats? Do you get full marks for 14 out of 40? No, you lose marks because it's not broken down. What I had to put the answer as? 7 out of 20. Okay. Okay. Part two. Right. Find the probability that all three animals picked were male dogs. Male dogs. Okay. How many animals were male dogs out of 40 animals, correct? And if you pick one animal, how many animals are left behind? How many animals were left? 39. And if we picked a male dog on the first go, how many male dogs are left? 10. And if we picked another male dog out, how many are left then? Out of? We're going to have to multiply all that and put it into, multiply all that and find out what the answer is in decimals. And what do we get? 0.017, because you have to round it off. Jump. All right. Now, that's 3 in a row. 3 male dogs, okay? Next one. 9 female cats were put in 6 separate pens. Work out the number of ways this could be done. Okay? I'm going to name my cats. Is that all right? With letters, not with anything else. Ready for this? A, B, C, D, E, F, G, H, I. Is that enough? That's enough. Everybody happy that's the first 9 letters of the alphabet? Any arrangement counts. A goes in pen number 1, B goes in pen number 2, C goes in pen number 3. I can change this around. See the way I can just change around B and A if I want? That's another way I could have done it, isn't it? And then we have to find out how many different ways this can go down. We're not going to write them all down, are we? Way too long, isn't it? Anybody have any ideas? How many options is there for the first pen? How many cats do I have to choose from? 9. I choose one of the 9 and I put them in. How many cats do I have left to choose for the second pen? Next pen. And what happens? All the way back down to 0. Okay. Now, you can do you know what I have to do here? I have to multiply 9 by 8 by 7 by 6 by 5 by 4 by 3 by 2 by 1. You can do it like this if you want. There's a button that does this for you. Is anybody familiar with the button that does this? Any of the ex-honors lads? The exclamation mark, otherwise known as factorial. So you can do that if you want. And you get 362,880 ways. Or you can use 9 exclamation mark. Anybody know where the exclamation mark is on the calculator? Anybody see it? Where is it? Shift X minus 1, there it is. And that will give you exactly the same answer. Okay. If I put in 5 exclamation mark, it multiplies 5 by 4 by 3 by 2 by 1. Okay, cool. Awesome. Oh, look at this one, more of this. By the end of this week, 10 of the animals have left the shelter and no new animals have been taken in. If an animal was picked at random at the end of this week, the probability of picking a dog would be 11 out of 15. Work out how many cats left the shelter during the week. Oof. Okay. Interesting. Okay. Damn. What's the current probability of picking a dog? So go back to your table. How many animals did we have? How many dogs did we have? Yeah. Okay. Okay. And how many cats do we have? 14. Okay. This is a very difficult question because I have to take out cats and dogs, don't I? Okay. I'll start taking out dogs. I'm just going to mess around with this and see what happens. I want to get to 11 over 15, don't I? So for example is if I take out 6 dogs, what's left over dog-wise? 20 out of 20 out of 34. And 20 out of 34, 11 over 15 is roughly 73%. Yeah. What's 20 over 34? 58%. Crap. I've gone too low, haven't I? Let's start taking out some cats. Take out 4 cats. What that put me on? 20 out of 30. So I took out 4 cats, yeah? Okay. Let's go again. I'm gonna go higher. I'm gonna take out another 5, maybe another 2 cats, maybe. So what's that then? 20 over 28. I'm probably too high now. What is 20 out of 28? 10 out of 14. All right. So that's another 2 cats, wasn't it? To be honest, I think what I'm going to do is I'm just going to take out another 9 dogs. What happens if I take out another 9 dogs? I'll have 11, won't I? And if I take out another, what's it, 13 cats, what will that put me down to? What? Yeah, how many cats did I take out in total then? 4 cats, 2 cats, and 13 cats. What? Yeah, I took out 19 cats. You see, it's a very messy method, isn't it? You're just sort of toying around with the numbers until it fits what you're looking for. So that's what I did there. I just kept going. I suppose if you're really honest about it, it's 26 out of 40, right? Yeah, that's what I had to do. I just had to mess around with the numbers until I got it. Right, that's a part E question, quite difficult. I think that's the way you do it, yeah. Yo, need another method. Thank you. So the method I just used is wrong because I'm not allowed to take out, what did I try to take out? I tried to take out 19 cats. And there was only 14 cats to begin with, wasn't there? That implies that I need to take out more dogs. Right, let's go again. Very good. We have another look at this. True is, I haven't done this question yet before, and if it was in a test, I'd be just toying around until I figure it out. To be honest, so you're seeing the experience firsthand. All right, let's let's take out. So what I'm going to do, see that ratio there, 11 over 15. I'm going to double that to 22 over 30. If I can aim for 22 over 30, that's the same ratio as 11 over 50. Does that make sense? Right. Take out 10 animals. How do I know I'm taking out 10 animals? 40 drops to 30. That's 10 animals. You cool with that? Okay. Nextly, I need to go from 26 dogs down to 22. How many dogs did I take out? We have to answer now. If I took out 4 dogs, it must mean I must have also taken out 6 cats. That was much easier. It was doubling. It was realizing I couldn't take out 19 cats. I made that mistake. And then I go, okay, what's the other way I could do this? If I can't get to 11 over 15, I can get to 22 over 30 because it's the same ratio. So that's the problem solving there.